Okay, Ji, so we were trying to do this example in the class today where we are trying to blink an LED at a rate of 0.5 seconds. So for every 0.5 second it will be on, and for the next 0.5 second it will be off. So it's just a toggle example. So this was a file shared by one of your class fellows. The code here is the way we would write it in the Arduino IDE. So I'm just trying it first to compare it with the one that we'll write. So I just run this code and you can clearly see that the LED blinks now 2 times a second. And to confirm it, I'm plotting this on the oscilloscope, and if you put a cursor on it, so one square wave of the oscilloscope, it starts, sorry about that. So the square wave, it started at, let's say, 0 second. This is our reference. And one square wave completes exactly at 1 second. So this is 1 second. Okay, so the time period is 1 second. So in hertz, we can say that that's just 1 hertz, the frequency. Now, if I bring in the code that we wrote in the using the CodeVision AVR, and I compile it here, we discussed it in the theory class. So the chip is a Mega 328P, and okay, no error, no compiler. The megahertz, the crystal frequency is 16 megahertz. So I take this code and I burn it in here. So we get the same behavior. So it's 2 times a second now. And you can confirm it again from here, oscilloscope. So it's giving us, it's not as perfect as 1 second, but it's 990 millisecond because we had the calculation very roughly. So, but at least it's much better than the previous version. So I'll share this Proteus file. I'll put it on the LMS, and I'll also share the code that we wrote today and using the CodeVision AVR wizard. So we just confirm one more time. Yeah. So it's roughly 1 second. Okay, using our code. And the calculations are the same as we discussed in the class. So we are running the timer for every 15 millisecond given 16 megahertz crystal and a prescaler of 1/8. So it becomes 15.625 kilohertz. And yes, we can confirm it here. 16 megahertz divided by 8. So no. Sorry, the prescaler is not 8, it's 16 megahertz divided by 15625. It's 1024 is the prescaler. Okay, so this value comes from 16 megahertz divided by 1024. So the prescaler is 1/1024, and you see the calculation here. So this gives us that the time rolls over every 15 millisecond, and if for 33, if we let the timer roll over 33 times, so 33 times 15 millisecond is giving you 495 millisecond, and that's why we're little off the 1 second in the Proteus here. but that's fine. At least we verified that. Now the compiler, the Atmel Studio compiler works with Proteus, so we'll be using this from now on. Thank you.